Let's convert from name to formula, or the reverse. Na2O. This would be called sodium oxide. When you have an ionic compound, meaning a metal followed by a nonmetal, we don't use monodi-tri. For example, when we say NaCl, we don't say sodium monochloride. However, if we had CO2, we would say carbon dioxide. So you have to check to see if it's a salt first or not. We've got a metal followed by a nonmetal, so no monodi-tri. However, iron, if you look at it, it's in that central part, the polyvalent region right there. These can have multiple charges, so we're supposed to specify them in general. And it's not really just limited to the D block, but that's where a lot of them are. So we're going to call this iron oxide, but let's leave a little space there. Oxides always have a -2 charge. To offset that, the iron must be +2. Ionic compounds overall are always uncharged. For some reason, we have to do that with a Roman numeral. So there it is. CO, you probably know this from experience. This is called carbon monoxide. And as we alluded to before, when it's not a salt, not an ionic compound, we do use monodi-tri. This is not for any sensible reason, if you ask me. It's just the way it evolved. So carbon monoxide for that. Now let's change aluminum oxide into a formula. Well, I guess aluminum is Al. An oxide is O. This is our cation, always. This is our anion, always. We always say cation, then anion. We don't say chloride sodium. We say sodium chloride. And we can look up their common charges and just put them there. Aluminum, number 13, has a common charge of +3. I'm going to make a little note. Oxygen, over here, has 6 valence electrons. It tends to form a -2 anion. And maybe some awesome teacher taught you the drop and switch method, which works just fine unless you have to reduce, right? But we don't. Al2O3 is fine. We can also explain it by logic. Since ionic compounds are always unstable, one of each are always uncharged, one of each would not work here. We need 2 +3s, that totals +6, to offset the 3 -2s. So we are +6 here, -6 there. It makes sense. Last one, copper nitrate. Well, they told you its charge. It is in that polyvalent region. There it is right there. And it's got a charge of +2. I'll make a little note of that. We don't need that in the answer. And for this one over here, we could get rid of our notes there. Watch my beautiful erasable pen. So we can write copper 2. And then nitrates, well, you got to look them up or know them. And perhaps you don't have them memorized, but you have a table like this that's alphabetical. And for nitrate, where are we here? Not nitrite, not nitride. Nitrate is NO3 minus, so I'll write that. I'll make a little personal note that it's -1, and then I'll do the wicked switch thing, but I can't write NO3 2. I don't want to write NO5. I need 2 of these whole guys, and only 1 of the copper, which we don't have to bother writing. So that's a little bit about converting from names to formulas.